All right, so in this video, I'll be going through the concept of graphs. So graphs are a particular type of data structure. It normally comes into play whenever you have a situation where you have many connections. So some of the areas you might want to think about is, like a social network where you have maybe person A, person B, maybe person C, and maybe they're all friends. Maybe they're all friends with each other. Um, so that's a really good way for you to start thinking where you can apply a graph, or maybe if you have something like a web page, and this has a link to that page, and so on and so forth. Then again, these are good places for you to start thinking about what's about a graph. So just because it's a data structure, it means that it is generally abstracted. So for the sake of simplicity, I'm going to start with a very simple graph that maybe looks like this. So this is a type of a structure called a binary tree, but will be useful for our illustration here. So let's talk a bit about the various concepts that are there. So when you think about it, a graph, these nodes, which are the areas that are connected, are called vertices. So this is a vertex, and the area that connects them is normally called an edge. So this part here is called an edge. So one of the things to realize then is if you have a vertex and an edge, you can very quickly introduce the concept of directionality. So that means, for example, you might find that this vertex and this vertex are connected to this edge only in one way. So that means if you are working, for example, you can only move from vertex A to vertex B. For example, let's say this is vertex C, but you can't move back. So that might be one of the things that can be added there. Maybe there might be things like weight. So you might say maybe this costs only one, maybe this costs two. What cost means is purely arbitrary. That might be useful in things like transport networks. Again, that's many to many kind of relationship. So imagine a scenario where, for example, you've asked Google for direction, for a direction to go somewhere. Then they can either they can tell you, okay, you can use a train, you can use a bus, and so on and so forth. Yeah, so that will represent the cost, where maybe in one area would be maybe maybe £1, going to this other side maybe it's £2 or something of that sort. So that enables you to get the cost of traversal, which takes me kind of to the next point, which is a path. So for example, if you wanted to go from point A to point D, so this is a path A, then B, then D. So this is a path through the graph which costs 3, right? So that's another concept to kind of remember. Now, one of the other things to now realize, okay, so there can be different types of graphs. So you might find, for example, your graph goes like this: B, then C, then D, then maybe C is connected to D, but maybe also C is connected to B, right? If you find yourself in this scenario, this this point, this is what you'd call a cycle, because then someone can use this path, find themselves in B, then B, then C, then back to B, then C, then back to B, and again, and things like that. Now this is a connected graph. So a connected graph means you can go from point A, B, C, and D in one smooth motion. Now, if for one reason or another this part did not exist, right? So now you had a node D, but there's no way for you to get to node D. That's what you normally call a disjointed graph or a disconnected graph. Something else to also remember here is graphs can have degrees. Say for example, item B here, there are two ways to get to it. So you can either get to it from A or get to it from B. So it has 2 in degrees. However, there's only one way to get out of it, to n in degrees, so there's only one out degree. That's something to also to consider when you're looking at your graph. Now, well, my diagram there looks all nice and stuff. The thing that you want to see is how do you represent this information in a computer, right? So if I had A, B, C, D, for example, then it looks like this, and maybe let me just introduce some other edges here for the sake of my example. So if you find yourself in this situation, well, what do you need to do? How do you represent this? Usually you present it using either something called an adjacency matrix. So in an adjacency matrix, let me just write it down because I know I am probably not doing the pronunciation any justice. So adjacency matrix. So that's what I meant. So if you're looking at it from the point of view of an adjacency matrix, what it looks is something like this. So you have an A, a B, a C, a D, and an E, right? Like that. Just however, basically you put the vertices on this side and this side, and then if there's a connection between those two, you put a 1. So for example, if you can go from A to A, then you can put a 1. Sometimes it's possible that you can just move from one node to the same node. Sometimes it is possible. You can imagine a situation where, for example, I have maybe like a homepage, so I can view other people's homepages, but I can also view my own homepage. So it's just within that node, it's just me. Anyway, so if A to B there's a path, then that's a 1. A to C there's no direct path, that's a 0. A to D there is no direct path, so again that's a 0. And then maybe B, so maybe I can assume that B to A there's a path. B to C, B to B, it's in itself. B to C, again there's a path, and then B to D there's no path, and so on and so forth, right? So that's how you'd fill this out. So you can store this information and you can use this to construct as needed. Another way to call it would be just to decompose this into a list. So maybe you do something like this and you would say, okay, connected to A is B, for example. Connected to B is A and C and D. All right. Connected to C is D, for example, and so on and so forth. So that's also another way for you to think about it. Now, the last big point I want to talk about here was traversal. So I've talked a bit about it here in this previous page. So when you looked at traversal, also previous video. So yeah, so we talked about traversal a bit, where you can go either one way, or as a directed graph, or rather than a directed graph, where you can go either ways. But also the point is that you move through it and create a path. So that's what it means to traverse the graph. Now there are strategies of going through it. Let me just go to a fresh page. Okay. So if you wanted to explore this path, let's assume, for example, you want to get the total for all of these numbers. So if you start at 0, maybe 1, 2, maybe 3, 4, 5, 6. So the question was asked to you, what is the total number of all the vertices? Like, what do they add up to? Well, a good way to go about it might be to say, I can either go all the way to the end, backtrack, go all the way through the end of this path, backtrack again, and then go back, backtrack, then go forward, like that. That might be one way to go about it. That's called a depth first search. So that means you follow the path all the way to the leaf node, backtrack one step, then go to the next, follow the next available path until you get to the end. Another way to do it would be to do a breadth first search, where you start from the root node. You only check everything that's immediately connected to that node before moving on. So check 1, then check 2, do any operation you want. So in our case, we were doing addition, so you can do addition of 1 and 2, and you get that number, and you continue summing that up. And then if you get to the item 1 again, you check all of it before you move on. So basically you must clear this level for the summations, then sorry for the exploration, then clear this level, then clear this level, and so on and so forth. So it's not that you go straight. So that, I think that's a good introduction. I'll be probably covering graphs in more details in future videos. Thank you.